All right, welcome back to 13.5. Going to learn a couple new things today. One is another way of finding the area of a triangle, and then that's going to fall us into something called the law of sines, which is going to allow us to find missing sides, missing angles of a triangle that is not right. Just any triangle you could use. You could use it when it's a right triangle too, but normally you'd want to use your right triangle trigonometry. So as we kind of look into some things here on the slides, it kind of shows the derivation of how we can use the area of a triangle and how to use that and convert that using some of our trig functions, the sine function particularly. And as we kind of get in there and we kind of synthesize this, well, you know, the base is this side, and to find this side right here, basically you're going to use the sine of AC times the sine of A to find that. That substitutes in for the height. So it's kind of interesting. What a formula comes into is if you use two sides of any triangle and you take it times the sine of the angle in between it, and then take half that gives you the same formula. It kind of converts in from that 1/2 base times height. We kind of get into here, and you can do that for any side. The thing is that you got to have a pair of sides, and then it's the sine of the angle in between it. So let's show you how that works in a setup here. Here's a triangle. This side's 3 and 4, and we have the angle in between it is 40. So what we're going to do is we're going to take half of 3 times 5 times the sine of 40. So just do that on the calculator here real quick. 1/2 times 3 times 5 times the sine of 40 degrees. Make sure you're in degree mode once again. Otherwise that messes it all up. Well, there's our angle. There's our area. It's 4.8. In this case would be square meters. All right, well, let's try that again. Again, the setup over here. Here it is, a triangle. You got to know two sides and the angle in between it. So we're going to take half of 8 times 12 times the sine of 86. So once again, 0.5 times 8 times 12 times the sine of 86. There we are. Close that up. And, oh, look at that. 47.9 square feet is what that would be. Kind of interesting, a little another way of finding the area of a triangle, where most of the other times you had to have a right triangle or know what the height and the base were. Well, now here's a solution to that. You don't need to have that anymore. So again, trig functions helping us out, making life easier for us. Now with that, here's something that can happen here. We know that no matter how we do that, we know those areas are all going to be the same because it's the same triangle. Well, as you kind of solve that a little bit, and kind of simplify, what you'll notice is that, well, the ratio of the sine of an angle and the side that it's across from would be the same for all of those. So that's kind of another way of finding sides and angles using what we call the law of sines. So if you take the sine of any angle divided by the side that it's across from, that ratio should be true. And we know how to solve ratios. We're going to use that cross multiplying, and we're going to solve that. Okay, so there it is. That's our formula, law of sines. All right, so let's show you how that works. So when it says solve the triangle, that means we want to find all of the missing angles and sides. Now, I would suggest that if we give two angles, let's do the easy thing first. Let's figure out what this angle is here. We know that the three angles of any triangle should add to 180. So if we add those together and subtract from 180, we're going to figure out that angle E is indeed 119. Well, okay, so now we can set up and solve. What you want to look for is an angle and the side across from it that you know. We have to know that pair. So we're going to set up that ratio, sine of 28 divided by the side it's across from, 15. That should be equal to any other sine of angle divided by the side it's across from. So let's just solve for D first here. We're going to take the sine of 33 over D. So be consistent, angles up top, sides on the bottom. And then what we do is we cross multiply. So let's just go ahead here and let's take 15 times the sine of 33 degrees. All right, and then what we're going to do is we're going to then divide that by the sine of 28 degrees. Do it all in one step. Works out pretty slick. Bada bing, bada boom. We know that that side is indeed 17.4, and that makes sense because angle F is 28, its side across from it's 15. So the side across from the 33 should be just a little bit bigger, okay, because the angle is spreading apart. So that 17.4 seems really reasonable to me. All right, now again, as we do this one here, we're going to set it up now again. Sine of 28 over 15 would be equal to, well, we figured out that angle E is 119. And then to figure out that side, we put the E down here. So this time let's take 15 times the sine of 119, doing that old cross multiplying, crisscross applesauce, as we sometimes say. We're going to divide that by the sine of 28. And there we are. We should get that side, 27.9, and that makes sense because, angle E is the largest angle, so the side across from it should also be the largest side, which indeed it is at 27.9. Okay, so for 13.5, two things to learn today. One is our new formula, finding the area of a triangle, and again, that's back in the slide here, and I try to incorporate those back with you. Those are those areas there, and then again, we have our law of sines, learning how those work. So feel free to refer back to those PowerPoints as you're working on the worksheets. And then, we'll kind of get those. Let me know if there's any questions. Again, make sure your calculator's in degree mode. And one more section that's coming up next. And until next time, I'm Mr. Bone.